1026, maximum difference between node and ancestor. So given the root of a binary tree, find the maximum value for which there exists a different node A and B, where value is equal to the absolute difference of A dot value minus B dot value, and A is the ancestor of B. A node is the ancestor of B if either any child of A is equal to B, or any child of A is the ancestor of B. So this is going to be another DFS solution, and basically what we would do is we would keep track of the maximum previously seen and the minimum previously seen, and then since there's only like two ways to get the absolute difference, which would be like the current root dot value minus the min, right? So this is if this would be the new max, and then another way would be max minus root dot value, and this is assuming that root dot val is the lowest we've seen. So there's a couple ways you can do this. So I'm gonna start with the solution and explain as I go. So like last video, we'll initialize an empty array. I mean, it could be an int, and we'll set it to 0. The number of nodes in a tree. Okay. And then what we'll do is we just return final. Then we have to do create the recursive function. So we do DFS, and then we'll pass in root, max, min. So first the base case, if not root, return. So that's just like if you go out of bounds, then it won't cause an error. And then here we can just update final. So we'll do, you could also do an array, like that's what I did last video, but it's also another way to do it. So we can do final equals max be the max of final, the max between final and max minus root dot val, and final max between final and root dot val minus min. So here the final would be changed to the new final if any of these are greater than final. And then now all we need to do is we just need to update the max and the min. So we can just go ahead and do that. So we can do max equals max between the current max, and then if root dot val, and then we can do min equals min and root dot value. So this is like just to update the max, and then down here we can do DFS root dot left. So this will just go down the left part of the tree, and then we could send in max min, and then DFS again, root right, max min, and now we just have to call it. So we'll do DFS root, and then here example for the max, we know that this, like the range is already here, so we could technically just send 10 to the power 5 plus 1, and that'd be out of the range. And then that would, because we want to send the max possible value at the beginning for the min, and then send the lowest possible value for the max, so that secondary on here they would both be initialized as this. So This time I'll just do the, we'll just call inf equals +1, and then we could just send in, for the max we'll send in negative inf, and then send in infinite for the min. And then let's run our code. Okay, let's submit. Okay, and it's pretty fast. Alright, so I'm gonna put my LinkedIn in the description. Just connect with me, like and subscribe, and then I'll post one tomorrow. Thank you.